Hi friends and my dear students. Today in 12th Physics second volume we are going to see 8.6.5 half-life. In last class we have seen alpha decay, beta decay and gamma decay and what are the different types of methodology that we are explaining the gamma decay. Now in this class we are going to explain the half-life of decay atoms, or any nucleus, or any radioactive nuclei. What is my half life? There's important things we have to understand first. Then we have to derive an expression for half life. Half life, if suppose you have to consider an element here are said to be enormously or accumulated here, and we are considered as total number of elements are said to be n. Total number of elements are said to be n. Then if you want to find out the time taken to decay completely for this n elements or n atoms or n nucleus of n atoms, I think it may take infinite years. Infinite years. We couldn't be able to find out the time taken of the decay decay time of the total atoms of samples that are given in there by means of the number as n. But why, sir? What is the reason for we are not able to detect the total number of lifetimes of all atoms accumulated here? We couldn't be able to find it. When you say one nucleus, then we can explain the probability chances when it may be decayed and how many times it will be taken. But when we are talking about the whole atom or sample space that are given by the n, then it may take until infinite years. It may be going on, going on, going on, so that it is very difficult to find out the total lifetime of decay time. That's why it is very difficult. Second concept, we can determine any portion or any fraction. Suppose if you want to find out n by 2, what is n by 2? The total number of nucleus available here is said to be n. Then n by 2 is a fraction of that is called the fraction of n. That is 1 by 2 of the total samples, or 1 by 4 of samples, or 1 by 8 of sample of atoms, or radioactive atoms, or 1 by 16. These all fraction are able to explain by means of any derivation. That's why the half-life is a very important concept to understand, to find out the fraction. Now, before I explain the half-life, you have to assume here there is a total number of nucleus is called N naught. N naught. When t equals 0, then the total number is equal to N naught. When t equal to t of, listen here, when the time taken is equal to t of means you have to reduce the half of the sample. That is, the decay which has happened, the one portion of 1 by 2 of the total atoms. The time that are required to reduce the total number of atoms into n naught by 2, that amount or that time that is required for that is called T of. That is the definition. That is the definition. T of is nothing but the total number of atoms initially are said to be n naught, then it may be reduced as n naught by 2. N naught by 2. That is 1 by 2 of total initial atoms. And time taken for that reduced of the half of the amount of initial atom is called T of. That is called half-life. Half-life. That is the definition of half-life. Now, we are going to derive an expression for T of. T of. Which is a very important concept, because for if you consider any radioactive substances, then you must know the half-life period of that radioactive substances. Unless in future in Keeladi or somewhere else in Tamil Nadu, there is a place called as Keeladi, is calculating samples and find how many years before it was used. That is on the base of half-life. Carbon dating. Carbon dating. If you want to find out a chapel which may be used by our ancestor before 11,200 400 years before, you can easily calculate the number of years when it was made by means of carbon dating. Carbon dating is the basic concept under the principle of the half-life. That's why half-life is a very important concept to understand about the radioactive substances, because it is continuously emitting the radioactivity so that until infinite years. So how many half-life is going on? For example, carbon 5200 years. Likewise, when you consider here, for example, some atoms have half-life period of 10 power 24, 10 power 14 years. T of some element, some XR element is equal 10 power 14 years. An element which is needed to reduce the half of the initial element in the and taken the T of time, that is equal 10 power 14. That means 70 is equal to called as crore. Remaining 7 you have to add crore like that. This is the total amount of the half-life periods of some amount. At the same time, this is a far heavier one, half-life. In the same manner, 10 power minus 14 second also half-life. This is the lowest half-life. This is the lowest half-life of some Y elements or Y atoms. When we say the lowest, it is decayed within 10 power minus 14 second, completely vanished. There is no radioactivity after the 10 power minus 14 second. That's why this is harmless. This is harmless. This will be harmful. Don't like that. Don't consider like that. This is more harmful than that one. When it is half-life is reduced, that is more dangerous, more explosive, more dangerous weapon than the half-life is higher. So when the half-life is higher, it is harmless than this one. When half-life is reduced, this is the most harmful forces harmful radiation which are ejected. That's a very important concept. You have to store in your brain. Okay. Now we are going to derive an expression for half-life period. Half-life period. Half-life period of any decay elements. Half-life period. Now, when you consider, suppose t, when t equal to 0, when t equal to 0, when t equal to 0, then the total number of atoms is said to be n naught. When t equal to t of, capital T of, then remaining that is equal to n naught, n naught by 2, n naught by 2. That is, the total atoms are disintegrated in half of the atoms are decayed, remaining of maybe here. This is called undecayed number of nuclei. Number of nuclei. Or for time taken to reduce such amount is called TF. That is called TF. That's why I am putting TF that is equivalent to the number of undecayed numbers is called N naught by 2 is undecayed nucleus. Undecayed nuclei or nucleus or samples. Now we can write one famous equation n naught by 2, n naught by 2, that is equal n naught into e power minus lambda t, n naught into e power minus lambda t, as per the radioactive substances, radioactive law. We already derived an expression for n equal n naught into e power minus lambda t. This is not available in your textbook. That's why you have to keenly observe these steps. It is not available in your textbook. Generally, we are giving, this is called radioactive law. N equal to n naught into e power minus lambda t. If n that is equal to n, this is called n, then remaining is called n naught by 2. Therefore, n equal to n naught by 2. N naught by 2. Therefore, n naught e power minus lambda t. That's why I have to write like this. N naught by 2 equal to n naught into e power minus lambda t. Okay. Now, both sides are n naught cancel to each other, remaining that 1 by 2 equal e power minus lambda into t. Very good. Or in other words, you can write 1 by e power lambda into t. Now, the reciprocal of this both sides, you have to consider the reciprocal of this 2 value, then 2 equal e power lambda t. Reciprocal of right hand side or left hand side, both, then these are 2 equal, because both 1 equal in the upper, 1 is equal to 1, 2 equal to e power lambda t. Now, we are taking logarithm both sides, exponential logarithm, then log of 2 base e equal to log of e power base e into lambda t, e power lambda t base e. Here lambda t is a constant, you have to take outer side lambda t log e base e. We know the mathematical formula, log of anything base same, that's equal to 1. Whatever it may be, x base x, y base y, e base e, or r base r, that's equal to 1. This is a famous formula. we are applying here, then log of 2 base e, 2 base e, that's equal lambda into t. Okay, are you clear? Now, here you have to understand what is the difference between ordinary logarithm and exponential logarithm. In ordinary logarithm, if you want to find out 2, that is equal to 0.3010. This is ordinary logarithm. We are taking logarithm of 2, that is called base 10. It is when you say 70, you are taking logarithm is base, that is called 10, not e, not e. If you say log of 2 base e, sir, what is the value of 2 base e? 2 base 10, that is equal to 0.310. How can we calculate this log of 2 base e? This may be modified like log n, natural log n, natural log n 2, natural log of 2. Exponential means natural log. It means that it is nothing but natural log of 2. Natural log of 2, that is equal to 0.6931. 6931. So that we can calculate T of here we have to give the equation T of e power lambda. Instead of t, you have to put, when t equal to t of, then you have to put here n0 by 2 means t of. Likewise, you have to put t of. Here also you have to put t of. Whenever you consider t, then you have to put t of, because t is equal to t of. That's why n0 equal to n0 by 2. That's why we are applying here t of life period, t of. Now here also t of. Are you clear? Here when t is equal to t of n0 by 2, n0 by 2, here we are applying t instead of n0 by 2, then you have to change the t into t of, like that. So this is the equation that you are applying here. Then n0 into e power minus lambda t power of, or n0 cancel, off into e power minus lambda t of, that is equal, or minus, it may be bring to the downwards, then e power lambda t of, or both upper equal to 1 and in the denominator 2 equal to e power lambda t of, therefore 2 equal to e power lambda t of. Then take logarithm both side, then 2 exponential of 2, log of 2 base e equal to log of e power lambda t of base e. Now log of base e base e equal to 1. Therefore lambda into t of. But we want to find out the value of t of, that is equal log of 2 base e divided by lambda. But here I already told this is a natural logarithm of 2. It is nothing but 0.6931. If you consider ordinary logarithm base 10 instead of natural logarithm base e, that is a major difference. This is ordinary log, it is natural log. This is natural log, this is ordinary log. Ordinary log means base 10, natural log means base e. Here natural log and the value of natural log of 2, or you have to like write like 2 by lambda, and this is a value equal to 0.6931 by lambda. This is a T of is equal 0.6931 by lambda. This is a T of equation for half-life. This is a very important equations for 5 mark questions of life of any decay of any nucleus. Half-life is given by T of equal to 0.6931 by lambda. Okay. Now, furthermore, we have to expand these equations to study about the mean life. What is my half-life? Before that, in last class, I already explained radioactivity, activity or decay constant. Activity is in terms of explained by capital R. Activity is explained in terms of capital R. Capital R. We know that now we derived an expression for T of that is equal 0.6931 by lambda. Are you clear? Now, if the number of atoms present in the at T equal to 0, when T equal to 0, number of atoms present is N naught. Okay. Suppose in the then it may be N naught by 2 in the first T of, in the second T of, this is called first T of. Second T of, it may be reduced as N naught by 4. It may be reduced in third T of that is equal to N naught by 8. In fourth T of it may be reduced N naught by 16 and so on, going on like that. This is a very important equation. Then we can write after n of life period, n of life. What is the equation of activity? Activity or decay rate? Activity or decay rate, which are given by equation R. This is we already studied about activity is called R or decay rate. R is equal to R naught by 2. R naught by 2 after n of time. After n of time means that is whole power n. Here R naught is constant, therefore 1 by 2 to the power n R into R naught. That is 1 by 2 power n. This is activity equation 1 by 2 whole power n and R naught is the famous equation that is explaining the n after n of time. In general, this is the equation for half-life period. This is called in the same manner, we are derived an expression for activity or decay rate. R is equal to 1 by 2 power n R naught. That is called after n half-life period. This is a very important 5 mark question. You must thoroughly study about this equation, and if you have any doubt, then ask me. and put comments. I will explain clearly about regarding this half-life. Next, we are going to mean life. Thank you. Next class we are going to see what is mean by mean life.